Nothing in this game is what it seems. With their new GPA-driven rendering pipeline using mesh shaders, they use the occlusion culling on meshlets in addition to the mesh, which is similar to what Unreal Engine 5 is doing with Nanite, adding super dense geometric details to the world. They also made a tool that would place triggers on the ground and make some raycast over time. Checking where the ground is and what physics materials are used, it allows to spawn dust, sand, leaves, grass, and even swarms of insects. The wind in this game realistically affects physics, particles, and cloth. The game designers could easily define indoor and outdoor areas that have different wind speeds with smooth, stateless transitions between the two. This system, built on sign distant fields methods, allowed the designers to use wind boxes as primitives that define a smooth global wind strength field. This system, coupled with their GPU skin foliage that is using up to 300,000 bones per frame, is bringing the nature to life in a way that is rarely seen in games. Their new shader-based vegetation system, based on a new skinning system, supports art-driven bone shader animations. It allowed the team to use full character-style rigs on all the foliage visible in the environments. Of course, no environment art breakdowns would be complete without some modular building kits analysis. But in this video, we will explore many other things that the team at Remedy Entertainment did to make one of the best looking games of this generation. Many interesting tech will be discussed, so get ready for this deep dive into the art and tech of Alan Wake 2. Let's start with our good old modular building kits. This game's environments are not built very differently than most modern games. It is using modular kits as a foundation. Here we can see the work done by Room 8 Studio, a famous outsourcing studio. We have many modules here. Building facades or back elevations, complete buildings, smaller building parts, stairs. We even have a broken bus kit. This is very interesting to see what was delegated to the outsourcing partner. And let's now look at the work of artist Raja Ghosh. The artist mentioned that he had to study timber construction videos and details to learn the basic concept of timber architecture. This is part of the job of any environment artist, learning new things all the time. Nobody can know every type of architectural style, so it's a constant learning experience. The artist is offering us a look at the thorough documentation he made for the briefing to their outsourcing partners. From the initial blockout to test gameplay metrics, to the timber structure kit, to the furniture kits, this is an amazing peek into the production process of this game. From the same artist, we have the rental cabins modular kit. He created the kit from scratch to finish. He is pointing out that other artists from the team contributed. Go on his ArtStation and make sure you check everything. The link is in the description. We can see how the kits were planned and how the cabins were assembled using the kits, both exteriors and interiors. There are more great posts on the artist's page. Make sure to check it out. Now, from senior VFX artist Pol Rius, we can see a custom tool that he created, the ground spawner. Using large triggers on the ground that will make some raycast over time, they check where the ground is and what physics materials are used. This allowed to spawn dust, leaves, grass, insects, and sand. The emitters were also rotating based on the wind's direction. We can take a look at it straight in their engine, Northlight. Another custom Lua tool made by the artist allowed to use triggers in the sky to spawn leaves, birds, and water droplets when it was raining. The new wind system was not working with different particles, however, so he had to make multiple effects with different speeds that were rotating and moving depending on the wind direction and intensity. Another very cool feature is the footsteps. There were basically two systems. A basic one for when the player would step and another for what the player would gather on their shoes. Using Substance designers, He made different footstep decals that spawn depending on different variables using two footstep systems, one registering to the contact material manager made by another artist. Another one on top of the normal footstep system that cast a decal where you step added an extra layer of detail. This system handled that if you step on dirt or mud and then go inside, you will cast dirt for some steps. This also spawned blood steps and wet steps if you stepped in water or blood puddles or when it was raining. All these decals could get combined so you could get blood inside the mud or wet soil, etc. A very nice touch for a game that can be slow-paced sometimes. If you're learning from these videos but are still struggling to put everything together into a full environment, that's exactly why I built my full course. You'll build the entire scene step by step in real time, understanding composition, scale, materials, and lighting, so you can apply the same process to your own worlds. These environments were created by students using the same workflow you will learn here. It's designed for artists who already know the basics and want to create a professional portfolio work, not just isolated studies. This isn't about learning tools, it's about learning how professionals build environments. If that's where you're trying to get to, you can check the link in the description. We now have to talk about the wind and the foliage in this game. The team needed more realistic wind for the game, and they did deliver. The wind system tech is built on signed distant fields or SDF methods where wind boxes are used as primitives that define a smooth global wind strength field. The wind boxes act like basic building blocks that define how strong the wind is in different areas, creating realistic and smoothly varying wind patterns between indoor and outdoor areas. We can see with the debugger that there's no wind inside the car that Saga and Casey are driving. This is done through defining a moving wind box that specifies that the inside of the car is a wind-free indoor area. This is the GPU bone visualization, the skeleton rigs animating all vegetation. Each line is one bone, with almost 300,000 bones in Cauldron Lake being processed every frame. The expensive primordial forest environments of Alan Wake 2 are brought to life through the new shader-based vegetation system. It's based on a new skinning system that runs entirely on GPU and supports art-driven bone shader animations. In Alan Wake 2, it enabled the team to use full character-style rigs on all the foliage visible in the environments. They are calling the new system art-driven here because the bone shaders expose an API with which artists can write their own shader code that hooks into the underlying system. So technically, artists could use it to animate anything they'd like. Foliage, objects bobbing up and down on water, power cables wobbling in the wind, etc. So this game is using Meshlets, which is a technology similar to Unreal Engine 5's Nanite. They are actually the building blocks or low-level data structures used to implement virtualized geometry, while Nanite is a complete, high-level rendering system built on top of those concepts. I will provide the link to the presentation of Erik Jansson, GPU-driven rendering with mesh shaders in Alan Wake 2 in the description. So for generating the meshlet data, they used Arseny Kapulkin's Mesh Optimizer library. The meshlet size is 64 triangles and 64 vertices for this game. After the meshlets, the bounds are needed for doing culling. Here are the bounding spheres from the Intel Sponza's example. It's simply a center and a radius. Then there are normal cones. Those are the axes where the meshlets are pointing at, and the cutoff is the spread. And this is the quantized value that needs to be dequantized on the shader side, but it is very compact. So that was for generating static geometry. But how about dynamic geometry now? For the foliage, as we've seen already, all of the vegetation is skinned. So how to update the meshlet bounds? They have a compute shader that runs over all the skin meshlet instances. For the bounding spheres, it's a wave active min and max on the vertex positions to figure out the center and radius. For the normal cones, they use a wave active min max on the vertex normals to figure out the cone axis. To get the spread, or the cutoff, they got the dot product between the axis and each vertex normal, and by getting the smallest number from that gets you the cutoff. This is how long it takes on Xbox Series X. Under 0.2 milliseconds for updating bounding spheres, and under 0.3 milliseconds for the normal cones. And this is in an area with a lot of meshlets. Here, the black areas are height fields. They also use mesh shaders, but are not visualized here. You can see that everything has meshlets here, foliage and characters alike. The pop-ins that you see are due to the use of Simply Gone here. You can see that the bounds are updating in the background. So with that many meshlets, the engine cannot draw them. It has to call them. So let's take a closer look. We have 200,000 instances, 4 million meshlets, and about 200 million triangles. Here's what the culling pipeline looks like. So there are meshes bound spheres. They then do frustum culling, then contribution culling, which is culling small objects on the screen, occlusion culling, which is culling objects behind other objects, and that's it for the visible meshes. And if this was the vertex shader pipeline, that would be all. But since they are using mesh shaders, they can do more culling. So this is a compute shader, and then follows by an execute indirect to another compute shader. By the way, a compute shader is a program that runs on a graphic card, GPU, to do general math and data work. Unlike regular shaders, it works outside the normal drawing pipeline. It handles massive parallel tasks like physics, particle systems, and AI by running the same code across thousands of threads at the same time. So we then start culling meshlets. And then, same as before, except for the normal cone culling, this is what is passed onto the mesh shader. Here is the impact of the different callings. Let's see it in action. So first, the frustum culling debug. Now let's check occlusion culling. Using the character Saga, look at Thornton there. He's gone, and so is the vegetation behind him. Now using walls as occluders, there we are. Only the terrain remains visible. Now a word on the channel's partner, Bundle Foundry. You can get several tutorials for a very good price here. Many bundles are added each month. Several bundles just launched. You want to check this out. Check out the price also. This is great value. This is a great opportunity to level up your skills at a great price. Links to the bundles will be in the description. There are many more interesting features from this game. The pervasive fog scenes in Alan Wake 2 are built upon improvements into how the engine renders transparency. They are using moment-based order-independent transparency to make see-through surfaces blend together smoothly, even when they have different levels of detail. During Alan Wake 2's development, Northlight did a complete overhaul of transparent rendering. They are now drawing transparency in 3 resolutions with MBOIT, which makes it possible to blend fog, transparent geometry, and effects seamlessly. In addition to better blending of fog and other transparent elements, they have improved pipelines to allow more fine-grained control over fog placement in the world. Combining all this to per-pixel transparent lighting and fog-affected reflections makes opaque and transparent elements fit together better than in their previous projects. Their fog also approximates multiple light scattering, giving it a thick and realistic look that improves atmosphere. Northlight switched to a completely new data-oriented game object framework during the development of Alan Wake 2. The new entity component system based model enables memory-efficient storage and makes parallel execution efficient and safe. The ECS framework also made it to their gameplay programmers' favorite tech list as it helped implement the case board, Saga's visual storyboard for gathering evidence. ECS meant that iteration was quick because adding new or modifying existing systems or game objects was easy, and performance gains were clear when saving and loading the caseboard. Alan Wake 2 called forth reimagining character control in Northlight. They built a new Voxel-Based character control that enables smooth navigation in cramped, complex, and dynamic environments. It makes character movement more natural and fluid. Internal dev notes described it as the characters won't bump or get stuck into objects in tight spaces. The team have added support for fully ray-traced direct lighting and combined this with improved denoising and indirect lighting algorithms with NVIDIA. Ray tracing in Alan Wake 2 is more accurate and robust than what has been seen in Control. Ray tracing also makes the animated foliage look amazing, now that all the geometry animation is authored and simulated using skinning. With Alan Wake 2, PC players can experience GPU and CPU setup permitting the latest NVIDIA DLSS innovations, DLSS frame generation, DLSS ray reconstruction, path traced in direct lighting. If you're an environment artist, here's the actual takeaway. And it's not go learn mesh shaders. It's that every system we just looked at exists to make life of artists easier. Meshlets mean you stop obsessing over poly counts on every single prop. The ground and sky spawners mean you're not hand placing every leaf and dust mote across a whole level. The foliage bones mean a forest reacts on its own. Nobody keyframed a single leaf. None of that is replacing the fundamentals of environment art. That part, the modular kit, the set dressing, the storytelling, that's still 100% on you. The tech just took the boring 90% off the table, so an artist could spend all their time on the 10% that actually matters. We could talk about the 90% 10% rule. That would apply here. That's the real lesson here. The best environment art tech isn't the tech that makes things look better. It's the tech that lets artists focus on the art. I'm also offering a AAA portfolio checklist that might help you figure out what's important for employers when applying for a job. The link is in the description. And a quick thank you to the members supporting the channel. Your support helps make these videos possible.